Alright, in this video I'm going to teach you about partial fractions. So in order to master the partial fraction, you will need to understand the pattern of the questions. So for the pattern of the questions in partial fractions, basically is it will break down into the 4 categories. So over here I'm going to explain about the pattern first, then only we go into the detail on how to solve it. So the first is they call it linear factor. So when they call linear factor, they basically all the factor here they are saying about denominator. So therefore, when I say linear factor, that means the denominator over here is linear. When I say linear, basically you should understand linear basically mean x power of 1. Okay, when I say quadratic, that means you can see the denominator over here, you will have x squared, being quadratics. Alright, so some student might argue that when both of the linear factor multiply, actually you get x squared. Yeah, you are totally right. But then when I say linear factor, we focus on the factor. We are not focusing on something that after they multiply. So therefore, when I say linear factor, no matter how many they have, maybe the next one is x minus 5. Okay, the whole expression over here, we still call it linear factor because the factor itself is the linear. Alright, so, but over here, we're going to focus on 2 linear factor, which is enough. Alright, the second patterns of the question is quadratic factor. So for the quadratic factor, you can see very obvious one. You will see the x square. You will see the x squared in the denominator here. Yeah, you will see x squared plus 3. So this is what the so-called quadratic factor. So that means the denominator should have the x squared. So you can see the square here. So x squared. So yeah, just like that. And then repeat factor is very similar to the linear factor. Just you see the denominator, you have the whole thing bracket square one. So basically this one I can say is repeat the linear factor. So imagine x minus 4 is a linear factor, but if I repeat it, that means x minus 4 multiply x minus 4. This is the reason why you get x minus 4 square, right? So therefore, if denominator over here, you can see the whole thing is bracket square one, so it's fall into the third category. And then the last part is an improper fraction. Improper fraction I will not cover here, but I will give you some example, and then I will make the next video about improper fraction. But over here, we will focus on the first 3 types first. Okay, in the first category, linear factor is very easy. If you see the questions given is the linear factors, what you can do is you just make it equals to, okay, you copy each of the linear factor here, and then you add an a for it. I will say a x plus 3 plus b x minus 4. Alright, so if let's say example, if I have a third term x plus 5, then what I will do is I will plus c x plus 5. So let's say I have one more term, let's say like x minus 6, so I will plus d x minus 6. Okay, alright, this is how we solve if we are able to recognize the question is a linear factor. This is what we will do. So but in this case we only have 2 terms, so we do not need the c and d. Alright, so we'll stop here. Okay, this is what you will do for the linear factor. Okay, for the quadratic factor, mean you will see x squared in your denominator over here, right? So for the term with the x squared one, you will need to add the ax plus b for it, and then this one is x squared plus 3. Okay, you can always remember something like this, like the power between numerator and denominators, the difference of the x powers should be always be 1. So you can see this x1, this x power of 0, this is x2, this is x power of 1. Okay, this is the idea of it. Right, but then you still have another linear factor, right? So you plus c x minus 4. Alright, so let's say today this one is x squared as well. Then what I will do is I will do cx plus d. Alright, but then I don't think you will see such a complicated partial fraction here. So I will assume this is just x power 1. So we just do plus c So this is what you are doing. So let's say these two actually like they swap the place. The x minus 4 is at the beginning and x squared plus 3 is at the back here. Then you can just change a little bit. That's mean let's say you have the example like this, x minus 5 over x minus 4 x squared. Because they are multiplied, right? Actually you can swap the place by yourself, or you really want to do like this, yeah, you can always do. This is x a over x minus 4 plus bx plus c. So I will change this one to bx plus c, x squared plus 3. Yeah, you still will get the same result, alright? This is just in case you see the different patterns, so I want you to know like how you're going to apply the a, b, and c, and when you need to add the x. So remember, when you see the quadratic factors, you always need to add the x first. Alright, for repeated factors over here, actually is quite similar to linear factor, but what you will do over here is, this is linear, right? This is just a linear, so I will just do a over x plus 3. Okay, so this is another linear, but it repeat, right? So what I will do over here is like I will do b over x minus 4, and then I plus one more, which is c over x minus 4 square. Mean you need to repeat it, but when you repeat the x minus 4 over here, one is just x the power of 1, the other one will be power of 2. Okay, this is how you will repeat the x minus 4 square. Alright, but so important to recognize the question. Make sure it is not into the fourth category, which is the improper fraction. So for improper fractions, the numerator power, I'm going to call some short form. The numerator power either will equals to the denominator power, or the numerator power will be bigger than the denominator power. When I say power, I mean the power of x. Power of x. That's mean you can see the numerator power of x here is x2. The denominator, if you multiply, after you multiply is x2 also, right? It's x squared. So basically they are equal, then it's improper fraction. So this one is an x cubed, right? If you multiply, it's x cubed also. So it's the same, right? So it's equal, then it's improper fraction. Or you might have something like x power 4, and then bottom is x plus 1 and x squared plus 5. Alright, you can see you multiply, you get x cubed only. The numerator power actually is bigger than the denominator power, then it's an improper fraction. You can see all the example here. This one, if I multiply, the denominator is x cubed, top is only x power 1, so the numerator power is less than denominator power. Same idea to this one. So therefore, whenever you find out the numerator power is equal to the denominator power, is in the fourth category, which is improper fraction. Improper fraction, the way you're doing it will be slightly different, so which is I'm not covering in this video, but I want you to know when you see the expression, which formula you should use. Alright, so before I end this video, definitely I will teach you like how to apply, and yeah, how do you get an A and B here. So let's focus on the first example first. Okay, basically it is quite simple, but yeah, might not be so simple for some students. So okay, let's use some space here. So let's say this is x minus 5 over x plus 3 x minus 4 equals to, so like what I do just now, x plus 3 plus b x minus 4. So normally the faster way I solve this kind of fraction question is like I will multiply the total denominator here, which is x plus 3 x minus 4, for every single one. Alright, so you imagine if I have x plus 3 and x minus 4, I multiply this thing, I can simplify it, cover it, right? So I can simplify the whole denominator, because x plus 3 and x plus 3 cut, x minus 4 and x minus 4 cut, I eliminate them, so I left x minus 5. So same idea, if I multiply the whole thing for x plus 3 and x plus 3 I cut, I still left an x minus 4 for a, right? So I will do it like this. Same idea for b. So if I multiply the whole thing here, x minus 4 and x minus 4 I cut, I still have the x plus 3. Alright, this is the first step, which is a very important step. If you know this, then the rest will be very easy, which you need to assume some value. You need to give yourself some x value in order to solve the thing easily. So in this case, I always want to make the bracket become 0, because 0 multiply a, you get 0. So what I will do is I will assume x equals to 4. That means I substitute x equals to 4 into the every x here. Alright. Okay, you might think like, how do I actually getting 4 here, because I want to make 4 minus 4 become 0. So after I make this one 0, the next step I will make this bracket become 0. Alright, so 4 minus 5, I get negative 1. Alright, this is 0, so the whole thing is 0, I just ignore it. So 4 plus 3, which is 7, so I got 7b. So my b is equals to negative 1 over 7. Then the next thing is I want to make this bracket 0, right? I will make x equals to negative 3. Negative 3, if I plug in here, I should get negative 8 here. Negative 3 plug in here, you will actually get 0. So negative 3 plug in here, you get negative 7. A. So my a is basically equals to 8 over 7. Then the next thing I will do is, I will plug in a and b into this equation. But pay attention how I actually put the things. Some student might insert the whole 8 over 7 on the top, but normally I will not do that. I will just do a, right? This is 8 over 7. I will write at the bottom. The 7 I write at the bottom together with this one. Because you should know 8 over 7 divided by x plus 3, you will get exactly this one. So I always do like this, 8 over 7. So 7 I will give to the denominator. Alright, this one just give you some idea. And then plus b, which is negative. So if negative, I will write minus 1 over 7 x minus 4. Alright, so this is how I get my answer. Of course, you can try to expand this one. You should get the same result. You should get the same result with this one. Why don't we just try it out here quickly. So if I were to like make them same thing here, so I will just join them together, right? That's mean I multiply x minus 4 here, x minus 4 here, I multiply x plus 3 here, I multiply x plus 3 here. So I trying to expand it, see whether I can get the same equation or not. Right, so the denominator we already settled. So this one on the top here, you should have 8x minus 32. This one you should have minus x plus 3. So 8x minus x, you get 7x. 32 minus 3 again, you get negative 35. So if you factorize out the 7 on the top here, you should get 7x minus 5. 7 and 7 I simplify, I get x minus 5 over the whole thing. So this is what happens for the partial fraction. Actually, it's quite simple. So same idea to the second part and the third part. So I will going to show you quickly. Let's try it out. So same idea. So I will just straight away do from this example, since I already have the question here, so I'm not going to rewrite it. So so the first step is I'm going to multiply x squared plus 3 and x minus 4 for the whole thing. When I say whole thing, I mean every single one. Alright, so I need some space for it, so never mind, I write in the green color over here. So you just imagine if I multiply the whole thing here, I can simplify, right? I left x minus 5 here. Alright, so if I multiply this one for the second one, this x squared plus 3 and x squared plus 3 I simplify, I should get ax plus b, and then I multiply with x minus 4. Alright, so same thing for the third term here. So if I simplify, I still get x squared, I still get c and x squared plus 3. Alright, then the next step, like as usual, so you will insert some value to make one of it 0. So in this case, maybe I insert 4 first. I make the ax plus b equals to 0. So I insert x equals to 4 here. So 4 minus 5, you get negative 1. So the whole thing is 0 because x minus 4 minus 4 is 0. So this one will be 16. 16 plus 3 will be 19c. So c is just negative 1 over 19. Alright. then maybe I sub x equals to 0 because I want to make a become 0. So yeah, if I sub x equals to 0 here, I get -5. Here I will get 0, so I left a b here. So this is -4, right? So we get -4b. So this one over here, we still have the 3c. So over here, since you know the c value, you can insert the c value here and you solve it out. -4b minus 3 over 19. Yeah, because this example I just randomly write, so you can see the number over here is a bit complicated. But yeah, you can just use a calculator to like solve it quickly. So it's -5 plus 3 over 19. So you will get negative 92 over 19 equals to -4b. So b will equals to divided by 4 again. So it becomes 23 over 19. Then I will just give another value for x in order to find my a here. So maybe I try. Yeah, you realize this one actually, no matter how you substitute, also you can't make it 0, right? So if in this case, yeah, you just substitute any value because you already have b and c, so you just randomly give any value to x, it's fine. So I use some simple value. I assume x equals to 1. So 1 minus 5, I get -4. So if a multiplied 1 is just a plus b is 23 over 19. And then this is x minus 1, so this is -3. Yeah, because 1 minus 4 is -3. Plus c, you have the c already, -1 over 19. And then this is 1 plus 3, which is 4. Alright, then you just solve this equation. You should be able to get a easily. So let's solve this one. So you should have -4. -4. And then I'm going to move the whole thing to the other side. It is plus 4 over 19. So this side you'll get -72 over 19. So the -3 you're going to multiply for both. So this one 19 times 3. So I have, I should have a minus 23 over 57. Yeah, this is very messy, I know. So -23 over 57, and then I will plus 72 over 19. I just moved the thing around. So I have 193 over 57. So I got my a by divided by 3. So I got equals to 193 over 171. Alright, so yeah, this is not a good example because when you insert it, it seems like super messy. But let's try it out. So if I want to insert the things over here, I have 193 over 171a plus 23 over 19 over x squared plus 3 plus c. C will be, okay, this one still okay, -1 over 19 x minus 4. Yeah, you might ask me how to simplify the first one. Basically, you try to see 19 and 171 have any lowest common multiplier or not. So I will try to use 171 divided by 19. Yeah, it's 9. So basically, you can multiply 9 here to make the number looks nicer a little bit. So it's 20. So therefore, this 193a plus 207 over 171, right? And then over x squared plus 3. As what I say, this one is always multiplied like this, right? So I will just write the whole thing at the bottom. 171 bracket x squared plus 3 minus 1 over 19 x minus 4. Alright, this is how to simplify it. Alright, so for the parts, third part, you are doing the same thing. So you multiply the whole thing over here for every single one, and then you try to insert some x values to find the a, b, and c. So like in this case, the x value you can try -3, 4, and so on. Yeah, if like 4 you already used not enough, then you can try to use any x like 0 or 1 to like solve the equation. Right, so I guess that's all for these questions. Yeah, I'm so sorry, like I simply choose any number here to make your partial fractions look so difficult. I mean, in your real exam, I think your partial fraction should be very easy. Alright, so yeah, maybe in the next video I will choose some simple example, and then at the same time I will cover about the improper fraction. Anyways, thanks for watching. If you have any comment, please post on the comment section below. Yeah, I will try to reply you as soon as possible. See you guys in next video. Bye.